Hello everyone. So, sine rule. Let's consider a triangle ABC. Okay, it's a non-right angle triangle, so we can't use Pythagoras to find a missing side or a missing angle. So we have to have some other strategy that comes up with. So I'm going to show you the proof for this. So the proof is very simple. All you have to do is one construction line. You drop a perpendicular through the apex to the corresponding side. So that creates two right angle triangles. And let's call this perpendicular H. So, using what we know about sine, cos and tan, I now know that opposite A is H and the hypotenuse, which is opposite in this little right angle triangle, is C. So that means that the sine of the angle at A has to be equal to opposite over hypotenuse. And similarly, if I look at this smaller right angle triangle, opposite C is H and the hypotenuse is A. So that means that the sine of C is H over A. Now, if I rearrange both these, I can get H equal to C times the sine of A, and I can get H equal to A times the sine of C. I can make the two H's equal to each other, so in other words, C sine A is equal to A sine C. And now, if I divide both sides by the sine of A, and at the same time divide both sides by the sine of C. So in other words, on both sides, I'm going to multiply both sides by 1 over sine A sine C. So let's see what happens when I do that. Well, when I multiply this by sine A sine C, the sine A is cancelled. I'm left with C over the sine of C. And if I do the same on this side, I'll be left with A over the sine of A. And this is your cosine rule. Any side divided by the sine of the angle opposite it would be equal to any other side in the same triangle over the sine of the angle opposite it. And this will work for any of the three combinations. I like to call it the pairs rule. You need two pairs for this to work. And the important thing is you need three pieces of information to find the fourth. Okay, so I'm going to show you this and how it works, and hopefully it'll make sense to you. So I'm going to draw a triangle here. So in this triangle, this is going to be 80 degrees. This is going to be A degrees. This is going to be 7 centimeters, and this is going to be 10 centimeters. Okay, so I'm missing an angle, but at the same time I'm also going to do another sum. Okay, and in this one, let's say this is going to be 14 centimeters, this is going to be 39 degrees, this is going to be X, and this is going to be 57 degrees. So we'll do this one first. So you'll see the algorithms are very similar for both of them. So again, we need pairs. So let's check we have pairs. Here's a pair, here's a pair. So I have two pairs. So now let's set them up. Side divided by the sine of the angle is equal to side divided by the sine of the angle. So now you can see I've got one full completed side and then one thing missing. That's all I need to do. Now, how do I solve this? So I'm going to show you the very quick method. This will work every time that the angle is missing. The angle will always be equal to the inverse of, take the fraction you know and invert it, and multiply it by the number you know. And it works every time. So to the nearest whole angle, that's going to be the sine inverse of sine inverse fraction sine 80 times 7 over 10. And that nearest angle, that's 44. Now, very similar for this one. This time the side is missing. So again, I'm going to start off similar by making the fractions. Side over sine of the angle opposite is equal to side over sine of the angle opposite it. Now, this time I don't have to do anything fancy. It's a lot easier. All I have to do if I'm missing the side is leave the fraction as it is and just multiply it by the other. So I don't have to change it or turn it upside down or anything extra. I'm just looking for the side. So fraction 14 over the sine of 639 multiplied by sine of 57. And nearest whole number 19. And that's how you do it. Okay? Now, for a bonus, you can actually use this to work out the area of a triangle. So let me show you that. So if you remember from junior cert, to find the area of a triangle, you need half the base by the height. Okay? So let me show you what I'm talking about. Let's say you have a triangle, and let's say you have an angle in here. Let's call it B. Okay? And let's say that's B over there, that's C, that's A, so that's A, and that's C. So if I want to find the area of this triangle, I'd need to get half the base by the height. Now the problem is, that's grand if you can find the base. So I'm going to draw in a base as if I knew what the base was. So, sorry, height. So remember, there's your perpendicular height. So usually I'd go half of A multiplied by height. And that would give it to me. But what happens if you can't find the height? What happens if you just have it without the height? So is there another way of getting the height in terms of the other angles? Well, we already know this because we know that B is equal to, the sine of B opposite over hypotenuse. Okay, so if I rearrange this, then H is equal to C by the sine of B. So if I substitute this in here, then the area can be equal to half of A multiplied by C multiplied by the sine of B. Now, if you look at that carefully, what does that look like in terms of our original triangle? Basically, it says that if I get the sine of the angle between two sides that I know, I can get the area. In other words, half the product of two sides by the sine of the angle in between them gives you the area. So there's a really handy way of doing it. Okay?